Alright, now that we have learned on how to calculate for minor and cofactor, and then let's see how to apply it in calculating determinants for higher order matrix. Okay, so the good news is, right, for the calculation of determinant using minor and cofactor, we don't need to really actually calculate all of the minor and cofactor to find the determinant. Okay, so as you can see here, the determinant of matrix A can be obtained by expanding along the ith row or the ith column. So it literally means that we just need to find the minor and cofactor. For example, this one, we can choose to find the minor and cofactor by choosing one of the row or by using one of the column. Okay, so usually when people want to calculate the determinant when it involves with higher order matrix and they're using the method of minor and cofactor, what they did is actually they try to find a row and or columns that actually has lot of zero. For example, this one. So when there's a lot of zero, it will actually later make it easy for you to calculate, because when you multiply 0, it will always become 0 later. Okay, if otherwise you choose those with numbers, meaning that you need to calculate all of them. Okay, so for example, if you look at the formula here, right, to find the determinant, you will later need to multiply the element with its cofactor. Right, all of the element with its cofactor, and then you sum everything. So if let's say you choose column number 2, so -1 times with the its cofactor, -6 times with its cofactor, 5 times with its cofactor, and 3 times it with cofactor, you need to calculate it 4 times. But if you choose column 3, as you can see here, you have 3 out of 4 zeros. So 0 times with cofactor, will know whatever cofactor that we have later will be equal to 0, because 0 times number will get 0, right? So this will be 0, this will be 0, and this will be 0. We just need to consider -2 times its cofactor. What is the value? And you get the determinant for this matrix, right? Let's try to look at this example. Okay, so for this one, find the determinant of the first row. Okay, find the determinant of the first row. So first row here is this one. As you can see, how actually we calculate for the determinant for higher order by using minor and cofactor is, first we'll need to find the minor and cofactor for each element for the first row here. But right, because of the formula later is element times with cofactor, so for this element and this element, we don't really need to bother finding the cofactor, because when we multiply it later, we will get 0. So what they did is actually they just ignore these two. Okay, so that's why if you look at the formula here, yes, it is A11 times with C11. So this, the element times with the cofactor of the first one, and you have A12 times C12, which is this element times with its cofactor, and then we have A13 times with C13, which is this element times with its cofactor, and the same goes for this one. So you have 4 things that you need to sum. But when it comes to the calculation, as you can see here, A11 and C11, they just put 0 because the element is 0. Everything times with 0 will get 0. Okay, so they just put 0 here. They don't need to calculate for the cofactor. So as for A12, right, A12 you have -1. So basically what they did is they input -1 as A, and then as for C12, okay, for C12, if you remember the formula of cofactor before is -1 I plus j times with the minor. So the way to calculate for minor is by doing this one or this, right? You cross multiply and subtract, remember? So that is how to find the minor by finding the determinant. So if you look at this one, okay, for A12, which is this one, right? So this is the row and columns of M12. So to calculate for minor, remember we'll need to calculate an element other than its column and row, which is -5 for 0, 0, -2, 0, -3, 6, -4. So this is it, right? So we have -1 here is the A12 times with C12, which is -1 I plus j, which is 1 plus 2, times with the minor of that 12, minor 12, which is, like I said before, -5 for 0, 0, -2, 0, -3, 6, -4, which is this. So this is for A12 and C12. Next is A13, C13. So let's see. A13 is 0, so everything times with 0 will get 0. So they don't really calculate for the cofactor. They just put 0 here. As for the last one, A14, C14, it is 2. So because of it is not 0, hence they need to calculate it. So for A14, it is 2 times with its cofactor of 1, 4, which is 1, 4. So we need to exclude this in the calculation of determinant. Hence that will leave us with this element. So -5 for 0, -6, 5, 3, 0, -2, 1. So basically, instead of calculating 4 elements with 4 cofactors, they will just need to calculate 2 elements. So they'll get here 20. Okay, so now they want to calculate for the third row. So for third row, as you can see, there is no 0 available here. So basically you need to calculate all of them, the cofactor of 4, 5, -2, and 6. As you can see here, right, you have 4 things that you need to calculate, and you still get the same value, which is 20. Just imagine that if they choose the third column where you have only one value that is non-zero, which is -2, meaning that you need to calculate for the other 3. You just need to calculate for -2 times with its cofactor, and you will absolutely get 20. Let us try to do that. Now let's try to calculate the determinant by using the third column, where we have a lot of zeros, so we don't really need to calculate for cofactor for elements with zeros, because again, anything times with 0 will get 0. So it is actually the formula will be A12, this is actually 1, 3, A13 C13 plus A let me write it down first. So this is the column that we're going to use. A13 C13 plus A123 C23 plus A23 C33 plus A43 C43, sorry, C43, which is this. And again, we know that for 1, 3, 2, 3 and 4, 3, all of them is 0, so we don't really need to calculate the cofactor for elements with 0. So for A13 C13 I just put 0, A23 C23 I'll also put 0, and for A33 we have -2 here, so I input the formula. So we have A33, which is -2, times with the cofactor. So this is the formula of the cofactor. Right, we have -1 I times j, which is 3 times 3 plus 3, and then the minor for 3, which is 0, -1, 2, -5, -6, -3, and 0, 3, -4. As for A43 C43, 0, so I just put 0. So basically for this one, I just need to consider calculating for A33 alone, because for everything else is 0. So let's proceed with that. So we know that first I will need to calculate for this minor. Okay, so this is for minor 33, and the way we do it is by expanding the first and second column, right? This one. So I expand the first and second column, I expand it to the right side. So I get this, so I multiply, cross multiply, minus with the other cross multiply. So this is how I do it, and I get -10. -10 for this minor. So I'll just substitute. Okay, so this is the formula, our formula just now, right? So yeah, this actually plus 0. So this I'll get the -10. So this is actually equal to -10. Okay, -10. So let's try to calculate it. So this is zeros, can be ignored, so we just bring -2 in front, -2. So -1 to the power of 6, you will get +1, and then times with -10, and that will give us 20. So again, let's check with other answer for other columns. So as you can see here, they say that to determine the determinant for metric A for any higher order metric, you just need to choose one column or one row. And for this question here, they choose the first row, they get 20, right? Which is the first row, and they also choose the third row, yeah, and they get the same answer, 20. As for me just now, I want to choose the third column because it contains a lot of 0, so I don't need to calculate a lot of cofactor, and this is what I get, 20. So the same value. So the tips here is when it comes to finding a determinant of higher order determinant, always choose a column or rows that contain a lot of 0. Okay, so you can try to do this by your own. Okay, after this we are going to talk about adjoint. Okay, so thank you.